To the untrained eye, a crime scene can appear to have no clues. But to a crime scene investigator, or CSI, they're everywhere.
This is the largest forensic teaching centre in the UK, run by the National Police and Improvement Agency. Here students are trained to gather and preserve evidence.
And this week, I'm joining them.
A stolen car has been found abandoned after a hit-and-run incident. But it's not for real, it's a mock-up, designed to put me to the test. My task is to gather hair and fibres from inside the car. I'm hoping these will help me pinpoint the thief from our volunteer suspects. Helping me is CSI tutor Paul Deering.
Hair and fibres need to be recovered very carefully because they can easily be disturbed within the scene and actually lost.
Before we start, Paul and I put on special suits so we don't contaminate the scene with our own hair and fibres. All of us leave a trail of hair and fibres wherever we go. Every day, the average person loses 70 to 100 hairs from their head alone.
There's quite a lot in here.
It's not uncommon with the velocity of the collision and the impact the head has with the airbag to find a fair amount of hairs.
Although only one of our suspects has hair of the length we've found, the others may have shaved their heads since the crime, so they can't be eliminated at this stage. Next, I collect fibres from the seat. Most items of clothing are made up of tiny fibres. Like hairs, these can easily be left behind.
The more fibres that we can recover actually makes the evidence stronger when the scientists analyse it.
Right, we've got all our evidence all properly packaged and logged. Now it's off to the forensic lab to see what it can tell us about our suspect.
Peter Grant is an expert in hair and fibre analysis. The first step is to look at our evidence under a microscope. Fibres look very distinctive when magnified, so identifying different types is straightforward. Naturally occurring vegetable fibres like cotton look flat and twisted. Animal fibres such as wool appear scaly, while synthetics look smooth and speckled. Can Peter help me identify the fibres I collected?
We got a garment that's made up of two different types of coloured fibre, but both acrylic.
So it's certainly a start, isn't it?
What we'd need to do now is to have the garment that we think the suspect may have been wearing, and then we can do a whole range of comparison tests.
One of these tests can separate the individual colours in the fibre dyes. Forensic scientists can then compare these colour fingerprints to see if they match. Next, we look at the hairs I gathered. Microscopic analysis of these can also reveal a great deal of information, such as the person's race, which part of their body the hair is from, and whether it's been dyed.
You've got a bit of a lump on the end of the hair there. What does that mean?
That's the root of the hair. This is something else we can tell about this hair, is that it's been pulled out and it's taken with it some tissue from the skin. That's the bit that we can DNA test.
Another tool available to the forensic scientist is the toxicology test. This reveals if a person has been taking drugs, because the chemicals in the human body get secreted into hair as it grows. This type of analysis was key in the case of abducted schoolgirl Shannon Matthews. When samples of her hair were analysed, various drugs were discovered, including some sedatives. This proved that Shannon had been drugged even before she was kidnapped. Back to my evidence, and with the help of Peter, I've confirmed my suspect is a white man with brown hair, wearing an acrylic garment with two colours. If these had been real suspects, I'd have found my man.
TV shows like CSI bring a touch of glamour into the world of forensic science. While we know such programmes aren't real life, the work of forensic scientists is very real and crucial in keeping one step ahead of the criminals.